Hello everyone. Today we start the important subject of engineering disciplines, that is a control system engineering. This subject is very useful in electrical branch, electronics and communication branch, electronics instrumentation and control branch of engineering and others. Why it is important? Because wherever the automation is required, the control system play a very important role. If we see the background of this history of the control system and introduction of the control system, we start it from a basics that the control system represented by a single block, and this rectangular block which we use to represent the systems, and this system have one input and corresponding one output. The arrow in the input side and output side indicate the flow of signal. If we see here in the name of control system engineering, it comprises three important words. One is system, another is control system, and third one is control system engineering. Suppose we define the system, then we can say it is a system may be represented by a interconnection of elements, components, and some other things. It requires the components, means sometimes it is required to use the passive components, then active components, and what type of input it is required. We give the input and we obtain their corresponding output. So in the graphical representation, the system which we consider is designed to meet out some objective, to fulfill the requirement for which we design the systems. And if system is a very general terms and we make it a specific purpose, then we can say it is a control systems. And if we use this control system for engineering applications, then the name of the systems is represented control system engineering. And this is the significance that whatever the system we design, we use the control action, and the application of this control system for engineering purpose is the motto of these subjects. And this subject is very common for all branch of engineering. It is helpful in GATE examination, engineering services examinations, and other state and central level examination, where these three important branch is the eligibility criteria for selection in different departments. So some books use the input and output for a control system. Some book use the excitation and the response. The meaning of all the previous and this one is same, because some people use input-output relationship for a control system. The second word, in second way, we can say the control system we give some excitation and we obtain their corresponding response. And the third one is the cause and effect for a control system. So these are the three terminology we interchangeably use for representation of a control system to define the basics of the control system, where we consider only a single input, single output systems, because it may be because whatever the control system which we are studying here is a classical control system, or in other words, we call it is a classical control system. And we call in another way, it is LTI systems. The meaning of LTI is linear time invariant. So in this graphical representation of this control system, the input part, which we represent by a mathematical expressions, that is x of t, and the system control system, it is represented by g of t, and output, response and effect is represented by y of t. It is basically input is a function of t, means it is a basically analog in natures, and whatever the terminology we use for the input system and output is a function of xt, gt and yt. These are the notation we generally use for representation of the control system in mathematics. So we just see here these the control system which we studied in this way is known as the classical control system. Classical means the control system start for a very basic way. Basic way means we can say it is a LTI systems. LTI means linear time invariant systems. Means we consider the system is linear and its properties are not changing with time. Then we represent this system by some under some constraints, because this control system does not deal with the real-time problems. For the real-time problem, we go for the another type of control system. We call it is a modern control systems. Modern control systems is non-linear and time-varying systems. If we see here, then another type of the control system, but it is not covered in this control system. But for understanding point of view, the basics you can understand in this way. It is a modern control system, and it is known as non-linear time varying systems, and we call this is a real-time systems. And whatever the graphical representation it is indicated here, it is basically a SISO systems. Another name of this is SISO systems. SISO means single input, single output. If we look at this block diagram, then you just see here we have only a single input, and here we obtain a single output. It's a control systems: input, excitation, cause, output, response, and effect. Sometimes we go for the real-time system. We call it is a MIMO system. MIMO means multiple input, multiple output. And this system is represented by state variable approach. But the classical LTI systems control system is represented by transfer function approach. This control system deal only the linear kind of systems where time invariant taken into the consideration, because we do the mathematical analysis of this control system, means what kind of input we are giving, what type of control system we consider, what type of response we are getting, to analyze this response by giving, because once the system is fixed, then whatever input we give, the corresponding output we obtain, and we just check the response by giving the different kind of input, and we obtain the conclusions. So in this case, we can say the control system engineering, where we consider the linear time invariant systems. So mathematical representation is very essential to do the analysis of any system. Analysis means the system is, the system, what type of system we are using here, what type of input we are giving here, and if both these input and system is given to you, then you are able to find out the response of the systems. And another very important parameter which we consider here, that is, here Laplace is very important tool which we use in the control systems, because this time domain analysis is and solving the time domain representation which we use to represent the control system. Basically, it leads a differential equations, means nth order differential equations, and solution of these differential equation is very lengthy and time consuming. So we avoid this, and instead of doing the analysis of this control systems in a mathematical analysis in a mathematical way, then we are not doing in the time domain. What we are doing, we just consider the systems first, and this system is system input output. We convert all these parameters into Laplace form, Laplace transform form, you can say like this form. And then whatever, means earlier we are in time domain, now we are in complex domain, or we can say S domain. Because if you see, then S is represented by sigma plus j of omega. Why it is complex? Because it consists real part and imaginary part. If both these parameter is there, then we can say it is a complex. And so S domain, here we obtain the nth order differential equations. or sometime it depend upon the system consist the different kind of the parameter. So some book use sometime that intro differential equations also. Intro differential equation. And if we take its differentiation, then finally we obtain the differential equations. But in S domain, we obtained linear equations. Linear equations you can simplify in a very simple way. No more mathematical is required. Only a standard formula which we use to represent it in the S domain, and whatever calculation it is required, you can carry it out here, and then we come back to the time domain by taking the inverse Laplace transform. It means we are moving from time domain to S domain, where in the S domain we do the necessary calculation, and after this we convert it again into the time domain by taking the inverse Laplace transform. So wherever we are in the doing the calculation, for the calculation purpose we move for the Laplace transform, and then we simplify it, whatever necessary calculation is carried out, and finally we convert it back in the same domain, that is the time domain, and we do the analysis like this. So the Laplace transform here play a very important role. Then we do the classification that the control system use the feedback, because what we are doing here, the feedback means part of the output we feed in the input through some block, and we feed in the input either in the additive manner or in the subtractive manner. On the basis of this, the feedback may be positive feedback or negative feedback. In control system, we generally use the negative feedback because it leads very advantage in comparison with the positive feedback, because positive feedback we generally use for oscillations purpose, and the negative feedback we generally use for the for stability point of view. Means now we introduce the term stability, and this we consider this in the later on. But here you just see the feedback which we use in the control system are two types. One is positive feedback and second one is negative feedback. Positive feedback we use for oscillations purpose. Oscillations. And generally we use in the oscillators, and it leads instability. So this is not useful for the control system. If we design any system for obtaining some desired output to fulfill some objective, means the oscillations instability does not involve in that system, means this positive type of feedback we generally avoided in the control system engineering. Then negative is feedback is very important, and we definitely use in the control systems, because negative feedback increase the stability of a system, and so many other advantages are there. But here we from the control point of view, otherwise you can derive the mathematical expression whenever we define the transfer function later on. But before this, you just see here two type of feedback we generally use. Then another classification we can say here, the continuous time or discrete time control system, because here is definitely you just see it's a function of time, then it is a continuous time systems. Continuous, if we represent graphically, then we just write here any term that is x of t, means here we can say t is the independent variable and x is dependent variable. The independent variable is generally represented on the horizontal axis, that is t, and we can say the dependent variable is represented on the y-axis or the vertical axis. So if we write here x of t, it represents that x is a function of t, means t is independent variable which is represented on the x-axis, and here is on y-axis or in vertical axis xt is represented, means x is dependent and t is independent variable. You just plot in like this, so we can say it is a continuous time systems. Continuous time means we are in position to find out the magnitude of this xt signal at any instant of time, so we call it is a continuous time continuous or control systems. Continuous time signal which we use for a control systems in the input as well as in the output is known as continuous control system. And another type of system is known as discrete control systems. In this case, it's discrete means it is represented in the binary forms. We can say binary means either it's 0, it represents in the digit forms, or in the step forms, but it's not a continuous function of time. So this is and the control systems deal the input and output in a discrete forms. We call this is a discrete time control systems. We represent like this. Discrete time control systems. These are some terminology or the basics or introduction part of this control system which we consider, and the one by one the CISO and MIMO we already discussed in the beginning, and then we can say the basic representation of this control system are classified in two categories. One is open loop control systems, and another is closed loop control system. Open loop means this is the type of systems where output is not linked with the input. There is no relation between the input and output. So we can say it is open loop means there is no loop, or we can say feedback is absent in this case, or we can say no feedback. Or here closed loop means loop is closed, so we can't say feedback is involved. And you just see here this open loop and closed loop control system represented by the graphical form in a blocks. So we represent like this. It's a simple type. No need. Here is systems, and here is some control element, or we can say controllers. Here it is connected with this, and here we give the input, and here we obtain the output. And note, this is absent. Dotted line indicate that there is no feedback involved in these systems. So similar to this, here system may be a plant or some other devices or something. Means whatever type of system which we consider, in this case, there is no link between output and input. Then we can say no feedback. The system is open loop control systems. And in closed loop control systems, we can use the rest of the things as it is, but one more block come into the picture. Here is plant, here is controller, and here is the detectors, or basically we can say here this new block come into the picture. Generally we represent like this. This is the symbol of error detector. Error, it detects the error, so we call it as error detector. And these two are the output, and this is the arrow indicate the flow of signal. Here we give here the input. This input is basically we obtain here output, and here we use some feedback. So we call feedback elements, and this is the block diagram of a closed loop control system. Here you just see here the feedback output is connected to the input by some elements, and these elements is known as the feedback element. Here what type of circuitry is for the feedback element, it depends upon the what application you are going to perform. So here we consider the positive sign, or here we consider the negative sign. It means this negative sign indicates that the type of feedback which we are using is basically a negative feedback. And here we compare these two signal, and error is generated. If both are same, then output is 0. And this 0 signal is fed here, means no control action is required on the plant, means whatever you want is obtained in the output. If it is deviate from this, then we can say the input and this feedback signal, there is some difference, then controller take action and to change the plant parameter to obtain the desired output. So this is the basic block diagram of the open loop and closed loop control system. If we compare these two on the basis of some parameters, so we can say first you can differentiate on the basis of feedback. So no feedback, here feedback is involved. This system is more stable in comparison with the closed loop control system, because whatever input you give, instantly output is obtained. Means no further repetition is required, no iteration is required. But here you just see some changes are there, then definitely initial the error signal is the amount of error signal is this, then error is reduced, it is indicated by this, then this, then this, and then this. So, and finally it becomes 0. So if we draw the graph corresponding this, you just see this type of response you are getting. If we plot with respect to time, then you just see some oscillations are there, and it is die out after fraction of seconds. But you can say the open loop control system is more stable in comparison with the closed loop control system, and we can say stability is only the um, uh, one serious drawback associated with the closed loop control system. The rest of the parameter are very good in comparison with the closed loop control system. And for automations, this closed loop control system is only the best systems, where once you design the systems, it automatically works without giving any continuous feedback. This system is more accurate, more sensitive. This is less accurate, less sensitive, but stability is more. Here stability is less. Here no feedback. Here feedback is involved. And this system is complex. This system is simple. This is less cheaper systems basically, and this system is costly. And these are the some difference between the open loop control systems and closed loop control systems.